So we're going to be graphing equations. And again, you know that something is an equation because of the equal sign. So what we're going to do is we're going to look at some parts of an equation. And I'm going to write something in what's called general form. Now get used to this. Get used to this idea because you're going to see it a lot. And you already have. Remember when we were doing area, for example? Area equals length times width for a rectangle. So yes. Remember, it was just all letters, wasn't it? And then depending on the problem that you had, you put in the numbers. Yes? Remember how to do that? Well, that type of notation is called general form, where they just use letters to represent the numbers.
Oh, wait, John, shut up. What did you say?
Shh, guys, remember you're on recording. All right, now, what are those letters called in algebra? Do you remember?
Yes, she was. Variables.
Variables, exactly. Don't forget, that's what they're called.
Yeah,
now, and occasionally, we have some letters that are reserved for certain uses. And we have one that's reserved for the gradient. Do you remember what letter they always use to represent the gradient?
Y. X. R. S. G. S. It's S. It's S. This is just becoming a random string of lights now. I remember it was something random.
It's M. M always stands for the gradient. Okay? I don't know. You can look it up. So here is the general form of an equation, and this is written in what's called gradient intercept form.
Shush.
All right, guys. All right, guys. So, gradient intercept form. So just looking at the name of this, there are a couple of things that you should automatically know that you could find from this form. First of all, from this form, you should be able to find the what? Gradient. And the second thing you should be able to find is the intercept. Now, we haven't talked much about intercepts, and so that's going to be the big idea from today. First thing we're going to talk about is the intercept, right? But you've probably heard the word intercept before.
Because you said it.
Okay. The word intercept simply means a crossing. So if we're talking about a line, that's where the line is crossing one of the axes. So crossing one of the axes. Now, it's not axis because I mean both of them. So axis plural is axes. And remember, we have an x-axis and we have a what?
Y-axis.
A y-axis, exactly, good. So we have an x-axis and we have a y-axis, right? So two of them are axes. So now, and because most line crosses both of these, you end up having two different intercepts. But for right now, we're not interested in the x-intercept. We're going to talk about the y-intercept. Okay? And the y-intercept simply means the place where the line is crossing the, what do you think?
Y-axis.
The y-axis. Okay? So everybody following me there? So is it rocket science?
Yeah, it is.
Do you have to read? Do you have to? So it's only it's just, okay? It's simply the space where the place where the line crosses the y-axis. So, say for example, we have a little graph like this. Doesn't matter. And we have this line. Okay? Then this point right there, where that line crosses the y-axis, is called the y-intercept. Okay? It's simply the place where the line intercepts the axis.
And then that one would be the x.
Okay? Right. And so in this case, that one would be the x-intercept. But right now we're only interested in the y. Later we'll look at both. But today we're just going to look at the y one. Okay? So think about what's happening here, because remember that every point on the graph is an ordered pair that has an x and a what?
Y.
A y, right? An x and a y. Well, if that's the case, then think about what it has to be if it's on the y-axis. The y-axis is the one that goes straight up and down, right? Well, if you're on that axis, guys, are you focusing? If you're on that axis, could you have gone to the right any away from the y-axis?
No.
Could you have gone to the left any?
No.
No. You have to stay right there in the middle at the origin. Now, can you go up or down?
Yeah.
Yes, you can still be on the y-axis if you go up or down. But you can't go to the right or the left.
You came off the y-axis.
Because you won't be on the y-axis anymore. Exactly. All right. Well, if that's the case, what number tells you not to move either right or left any, do you think?
0.
0. So for the y-intercept, the x value is always 0.
For the what?
For the x value of the point. Remember, every ordered pair has an x and a y value, right? So the value has to be 0 because you can't move right or left any. Okay? Now, you can have a y value, and that y value is just determined by counting however many places up or down until you find where the line crosses the y-axis. Okay? So, let's go to Education Perfect and talk a little bit about some of these so you can see some of this in action. All right? So again, remember, the gradient isn't the only important part of the graph.
Is there Education Perfect in Lake Texas?
So, move on. All right? So let's look at this one. All right. So say we have the relationship between x and y. So here we have a graph, we have a chart, right? And we know that these numbers have relationships. Specific x values go only with specific y values. For example, if x is 2, what does that make y have to be? 5. Can't be anything else, right? If they have a relationship, then they have to go together always. Remember from those linear patterns. We looked at that when we were doing our linear patterns. Okay? Then, if that's the case, then you can graph that linear relationship on the Cartesian plane. Now, this Cartesian plane is only showing 1/4 of it. It doesn't go all the way, the x and y values, x and y axes. But I can still see the point at which this line would cross, if it did show the whole graph, or it touches it. Where does this line, it's not actually crossing, but touch the y-axis?
On the 1.
Exactly, where the y equals 1. Okay? So it doesn't go all the way to the origin. It starts right there. So that starting point on the y-axis, that point is the y-intercept.
Well,
Do you see it?
yeah, because it's like touching the y.
Right, because it's on the y-axis.
Yeah.
Got it? Okay? That's all there is to it. So you're just looking at where it crosses or touches the y-axis. So, and then they're just doing what I just did, circling it. So, looking at this graph, okay, right? Does this line cross the y-axis?
Yes.
Sure it does.
Yeah.
Where does this line cross the y-axis?
-2.
At -2. So therefore, the y-intercept is -2.
Yeah, so is that all the intercept is?
That's it. How easy is that? Everybody pretty happy with that?
Yeah.
Okay, good. Okay. So, and in many points, the y-intercept is the starting point of a graph if you only have that one quadrant. So look at this graph. This graph is talking about volume of water in a bathtub over time. So what happens if you have the tub and you pull the plug? What happens to the water? It goes down, right? Now, does it instantly disappear? No, it goes... Okay, guys, it goes slowly down over time, doesn't it? Okay? So if you look at this graph, where does this line, touch the y-axis?
50.
At 50. And
50.
Since it's 50 liters, that means when we started, before we pull the plug,
There was 50 liters of water in the back.
we had 50 liters in. The y-intercept is where this graph starts. Now, what do you notice about the line as it goes on? It goes what? Down. Because the amount of water that you have in the pub is going what? Down. And it takes more and more time. Over more and more time, you get less and less what?
A volume.
Volume of water. Makes sense? Okay.
Yeah.
Good. So you can use the y-intercept to answer questions. It's usually the starting point for most graphs. So we started with 50 liters of water, and then we moved on from there. Okay? Right? Good. All right, so this is part of your homework. We're not doing that. So next thing we're going to do is we're going to look at an equation of a line. So let's say we have the rule for a relationship. So in this case, the rule for a relationship is simply this equation. Looks kind of familiar, except they didn't use capital T and N, right? But do you always have to use capital T and N?
No.
No, they can be just as long as it's two different letters, it doesn't matter. So here is the equation. Y equals 2x plus 1. Okay? Guys, now, we could graph a line by just finding a bunch of points and then plotting them.
No.
Right? But there's an easier way. We can instead use this equation to graph the line very quickly and easily.
I know what's the other quick thing.
Okay? So let's look at how.
Oh, what's the point of Googling it?
Okay? When you have, hold on guys, when you have an equation, this is the general form for the equation. Remember I told you I was going to write it in general form? All right, this is the general form for the equation. Where y and x are just y and x from the graph, right? So we're not worried about those. What we're interested in is m and b. Those are the two things that will allow you to graph a line by just looking at the equation. Okay? What does m always stand for? We already talked about that.
The gradient.
The gradient, right? And remember that gradient is rise over what? Run. So that part we're familiar with. What we don't used to, I'm sorry, let me change this for a second. Don't put B, I forgot. In New Zealand, they use C. Okay? I don't know why, but anyway, it stands for constant. So C. No, it's fine. But you may see it as B occasionally. In books that are written in the States, it says B as B. It's fine. The C is the Y-intercept.
What does B stand for?
Okay? It's just a letter that's being used to represent the variable. So it's not specific.
It can be anything.
Right.
It can be any letter.
It can be any letter.
So why do we always use M for gradient?
Because it helps make it clear that you're looking for gradient.
Yeah,
Okay?
but what if somebody uses
All right.
X stand out?
I can't use
So,
G
guys,
gradient.
this is not...